Here we have an example of the use of de Moivre's theorem. We've got cos3 theta, and we want to express it in terms only with cos theta and powers of cos theta. So if we go back to our memory of what de Moivre's theorem was, it's cos theta plus I sine theta, all raised to the power of 3, is equal to, using de Moivre's theorem, we multiply the power times the argument, so it'll be cos 3 theta plus I sine 3 theta. Okay, so here's this was our trigger, that we want cos of 3 theta. So we went to the power of 3, and that gave us cos 3 theta here. If you cast your mind back to binomial, we need to be able to expand out to the power of 3. So let's expand this left-hand side. So the left-hand side is equal to, I'll just write it out again, I sine theta, all raised to the power of 3. And this is like an expansion of a plus b, all raised to the power of 3. It'll be cos cubed theta plus. Now, the numbers, the coefficients go 1, 3, 3, 1. You can either use Pascal's triangle to work out those. So we've got plus, so we've got the 1 in front of there. Now we've got to go 3, powers here go down, cos squared theta, I sine theta, power 1, plus, next coefficient is 3, powers of cos are going down, cos squared we've got over here, so cos theta, I sine theta to the power of 2, plus, coefficient is 1, I sine theta, all raised to the power of 3. So the powers of cos are going down by 1, and the powers of sine are going up by 1. Okay, now we want cos 3 theta, and you'll notice up above here that we only want, this is only the real part of this identity up here. So this is the real, and this is the imaginary. So what we can do, because this here is has been expanded to give us this expression here, we're not interested in the imaginary, we can equate the reals in here. So we've got this expansion here, equate the reals, and in equation 1. So the real on the right hand side would be cos 3 theta. This is going to be real. Now that is going to contain an I at the end when we multiply it all out. So that's going to be an imaginary part. So we don't include that. When we square this here, we're going to get I squared. So we're going to get negative 3. And we'll get sine squared. So this is going to be real when we square I, get negative. So this term here is one we need. It's minus 3 cos theta sine squared theta. I'll come back to that and explain that one again in a minute. When you cubed I, so you've got I squared is negative 1, and then I cubed, we're going to multiply both sides by I, is negative I. So when we expand that out, we'll get sine cubed negative I. Sine cubed theta negative I. So this will be an imaginary part. So we don't want that one either, because we're equating the reals. So going back to this one here, how does this become a real? That one's a real, obviously. This one here, when you square I sine theta, you get I squared sine squared theta. I squared is negative 1, which means that this will become, instead of plus 3, it becomes minus 3 cos theta and then when you square that you get sine squared. So we've equated the reals back here, we've expanded that right hand side and then used just the reals of that to come up with those two terms. Now the question asks us to express cos3 theta, okay, we've got that bit there, in terms of powers of cos theta. Well, there's a power of cos theta. We've got a cos theta here, but this is not in terms of cos theta. And if we go back to the Pythagorean identity, we know that the sine squared of any angle, we'll call it theta, plus the cos squared of the same angle is always going to be equal to 1. It's called the Pythagorean identity. So this sine squared theta here make it the subject of this formula here will be 1 minus cos squared theta. So instead of that sine squared theta there, we can write 1 minus cos squared. So why don't we do that? So we've got cos cubed theta minus 3 cos theta outside of, now instead of sine squared theta, we've got 1 minus cos squared theta. Tricky, tricky, tricky. We've got a minus outside a bracket, and inside that that's got a minus. So let's write the first term out. Now, if you like, you can think of this as negative 3 cos theta times 1, so that's negative 3 cos theta. And then we've got negative 3 cos theta times negative cos squared theta. So a negative times a negative will be positive, and then a 3 cos cubed theta. So cos theta times cos squared is cos cubed. Negative times a negative is a positive. The 3 has got to be at the front. Cos the power of 1 times cos the power of 2 is cos the power of 3. And then we have a look, see if there's any like terms, and there are. There are cos cubed theta and 3 cos cubed theta, and we've got to add those two together. So this is like one lot of them plus another 3 lot of them, so that's 4. So that's 4 cos cubed theta minus 3 cos theta. Go back and have a look, see, make sure we've answered the question properly. Express cos theta in terms of power of cos theta. That's certainly in terms of cos theta, and that's certainly in terms of cos theta. So we're there, that's the answer.